Welcome. Today, we're digging into a pathogen that, while it's not found in the Netherlands, is absolutely a crucial one to have on your radar for any lab that deals with travel medicine. We're talking about Colorado tick fever virus.
Just so you know, all the information we're going to cover today comes from a comprehensive deep dive into the latest research and public health data. We've synthesized it all to give you the most relevant takeaways for your work.
Right. It's a fair question. Why should a lab here in the Netherlands worry about a virus from across the Atlantic? Well, with global travel being what it is, imported diseases are a daily reality. And this particular tick-borne virus, it presents a really unique diagnostic puzzle and a pretty significant public health issue that you need to be aware of.
So here's our plan. We'll kick things off by establishing why this virus is relevant here, then we'll profile the virus itself. After that, we'll walk through the clinical picture, the diagnostic pathway for your lab, and wrap up with the critical management and public health controls. Let's jump right in.
Okay, first things first. Let's really nail down why this virus, which is typically found in high-altitude regions of the western US and Canada, should be on your radar here in the Netherlands.
So imagine this. You get a sample from a patient. They have a fever, and they've just come back from a hiking trip in, say, Colorado or Utah or maybe Alberta, Canada. Right away, this virus has to be on your list of possibilities. Its symptoms can look a lot like other illnesses, which means that travel history, well, that's your single most critical clue.
All right, so to really get a handle on this thing, we need to look under the hood at the virology itself. Understanding the virus's fundamental profile is absolutely key to grasping why it behaves the way it does clinically and why it can be so tricky.
So, Colorado tick fever virus is a double-stranded RNA virus. It used to be in the Bunyaviridae family, but now it's been moved to its own family, Bunyaviridae. And that name is a clue. It's because of these distinctive little spikes on its inner capsid. And that non-enveloped double capsid structure, that's what makes the virion so incredibly stable.
And here's the formal breakdown for you. It's the type species of its genus, cultivirus. And here's a fun little piece of trivia. The name cultivirus actually comes directly from, you guessed it, Colorado tick fever virus. Now, the really key feature here, the thing to remember about its architecture, is its genome. It has 12 distinct segments of double-stranded RNA. This segmented nature, well, it allows for genetic reassortment if a host gets co-infected with different strains, and that creates this potential for rapid evolution and, you guessed it, can make diagnostics pretty challenging.
Okay, so what does this virus actually do once it gets inside the human body? Understanding its game plan explains both the clinical signs a patient shows and the key lab findings you're going to see.
This right here is a classic clinical clue. In about half of all patients, you're going to see this biphasic or saddleback fever. What's that? It's an initial high fever, then a short break where the patient actually feels better, followed by a second, usually milder fever. If you see this pattern in the clinical history, your suspicion should go way, way up.
So here's the really crucial part. The virus specifically targets hematopoietic cells in the bone marrow. This explains that characteristic drop in white blood cells and platelets that you'll spot on a blood count. But here's the kicker. It then hides inside maturing red blood cells. It's like a perfect hiding spot, shielding it from the immune system. This leads to a remarkably long viremia, and, as we'll see, that has a huge public health consequence.
And that brings us right to your doorstep, to the laboratory. For you, identifying this virus is all about choosing the right test at exactly the right time.
Well, the answer depends entirely, and I mean entirely, on when the patient shows up relative to when their symptoms started. This is definitely not a one-size-fits-all diagnostic situation.
As this table makes really clear, you're looking at two very distinct diagnostic windows. In the first couple of weeks, it is all about direct viral detection using RT-PCR. After that, once the immune response has had time to kick in, you switch gears to serology. Getting this timing right is everything.
Let me put it as simply as possible. If a patient presents within the first 2 weeks of their illness, you must use RT-PCR. A negative serology test during this early phase is absolutely meaningless. It cannot rule out the infection because the antibody response is just way too delayed.
Okay, this brings us to our final and honestly most critical section. What happens after your lab confirms the diagnosis? What do we do?
The number one thing to remember for patient care is that there is no magic bullet here. Treatment is entirely supportive. That means focusing on hydration, rest, and just managing the symptoms, the fever and the pain.
Now, you need to be especially vigilant with kids. They are much more prone to severe neurological disease, things like meningitis or encephalitis. And the critical, non-negotiable point for any viral illness in a child, aspirin is strictly off-limits because of the risk of Reye syndrome.
And this brings us full circle, right back to that unique way the virus works, and its most important consequence for public health here in the Netherlands. That long-lasting viremia. It isn't just an interesting biological quirk, it is a direct threat.
So, your lab has a confirmed positive case. What is the one action that absolutely must be taken? Well, the answer is directly linked to protecting our national blood supply.
Remember this number. It's the crucial takeaway. 6 months.
You have to make sure that any patient diagnosed with this is clearly, emphatically instructed not to donate blood or bone marrow for a full 6 months. This deferral period is absolutely essential to eliminate the risk of passing it on through a transfusion and to safeguard the patients who need those products.
In our incredibly connected world, the next imported case is always just a single flight away. Knowing how to spot it, and more importantly, what to do about it, is truly our first line of defense. We really hope this briefing has been valuable. Please subscribe for more, and we'd love to hear your thoughts in the comments.